Hello everyone, I'm Tiffany Jules Maxilom, and today I'm going to discuss about statistics and probability by identifying the appropriate rejection region for a given level of significance when the central limit theorem is to be used. Here are the objectives. First, illustrating central limit theorem. Second, define the level of significance, rejection of region, and the central limit theorem to be used. Third, by the end of this lesson, learners will appreciate the importance of identifying the appropriate rejection region for a given level of significance. The central limit theorem states that if you have a population with mean or symbol mu and standard deviation or symbol sigma and take sufficiently large random samples from the population with replacement, then the distribution of the sample means will be approximately normally distributed. What is the significance level? The significance level, also denoted as alpha or symbol alpha, is the probability of rejecting the null hypothesis when it is true, or we aim to reject the null if it is false. What is the rejection region? It will depend on how big should Z be for us to reject the null hypothesis. In a two-sided or two-tailed test, there are two cutoff lines, one on each side. When we calculate Z, we will get a value. If this value falls into the middle part, then we cannot reject the null. If it falls outside in the shaded region, then we reject the null hypothesis. Ito yung ating normal distribution. If the value fall and the value of the same value falls into this part, to the unshaded, we cannot reject the null hypothesis. So it means we have to accept the null hypothesis. If the value of the shaded value, so computed, if it falls into the shaded region, we have to reject the null hypothesis. This shaded region is called the rejection region. Here we have the critical value of Z or the Z table. Alpha 0.10, 0.05, 0.03, 0.02, 0.01. For the confidence level, how to get the confidence level? 0.10 is equal to or equivalent to 10%. 100 minus 10% is equal to 90%. Ganun po ang pagkakuha natin. Or 1 minus 0.10 is 0.90 times 100 is equal to 90%. Mapapansin nyo, meron tayong 90%, 95%, 97%, 98%, and 99%. Now, let's look for the value of the shaded table. We have one-tailed directional and two-tailed non-directional. So, pag tumapad tayo sa 0.10 or 90% of the confidence level, we can use 1.28 for one-tailed and 1.64 for two-tailed. And for 95% of confidence level, we can use 1.64 in one-tailed and 1.96 in two-tailed. And the 97% of confidence level, we can use 1.88 in one-tailed and 2.17 in two-tailed. And for 98% of confidence level, we can use 2.05 in one-tailed and 2.33 in two-tailed. And for 99% of confidence level, we can use 2.33 in one-tailed and 2.58 in two-tailed. Now, these are the values we can check from the Z table. When alpha is 0.025 and Z is 1.96, so 1.96 is on the right side and negative 1.96 on the left side. Therefore, if the value we get for z from the test is lower than negative 1.96 or higher than 1.96, we will reject the null hypothesis. Otherwise, we will accept it. Therefore, kapag ang ating na-compute na z value is lower than negative 1.96 or higher than 1.96, halimbawa 2.5, therefore, we reject the null hypothesis. Otherwise, or the opposite, we have to accept. Central limit theorem. If random samples of size n are drawn from a population, then as n becomes larger, the sampling distribution of the mean approaches the normal distribution regardless of the shape of the population distribution. Sa madaling sabi, gagamitin natin yung central limit theorem kapag yung population natin ay hindi normally distributed. So pag sinabi kasi nating normally distributed, iba yung shape ng ating graph. Parang pa-bell shape. So what if kapag yung population natin ay hindi siya normally distributed, hindi siya pa-bell shape, dyan papasok ngayon si central limit theorem. Once na tinaas natin, nag-increase tayo ng sample size, habang nag-increase ng sample size, papalapit tayo sa normal distribution. So, yung population natin, papalapit na maging normal distributed population natin. Computes for the test statistic value population proportion. These are the objectives. First, computes for the test statistic value population proportion. Second, interpret hypothesis test for a population proportion. Then third, by the end of this lesson, learners will appreciate the importance of computing the test statistic value population proportion. We'll discuss computing test statistic value involving population proportion. So to compute the auto-test and to compute the computed value, we're using the two tests using this formula. Where this is the z-test computed value, and this symbol that is for sample proportion, kung saan nakakompute natin ang sample proportion by dividing x over n. And P is the hypothesized value of the population proportion. And N is the sample size of the number of observations in the sample. And Q is equal to 1 minus P. So, ito ang gagamitin natin for z-statistics for population proportion. For example, determine the computed value or the z-computed value given the following information. So the population of hypothesized portion is 0.35. N equals 180. Sample proportion is 0.40. So in order to compute, the z-test computed value, kunin muna natin yung value ng Q natin. So, Q is equal to 1 minus P. Since yung P natin is 0.35, so 1 minus 0.35, the answer is 0.65. Ito lang naman ang importante. Kailangan makuha natin yung hypothesis proportion natin, and N, and yung N, kailangan makuha yung sample proportion or yung Q natin. This one. So using this formula, substitute all the given data on the formula. So that is 0.40 minus 0.35 over the square root of 0.35 times 0.65 over 180. Now, kung ako sa inyo, gamitin nyo, i-direct nyo to sa calculator. Kasi, kapag nag-round off tayo, dito sa, halimbawa, kukunin nyo muna itong sa denominator. Ito sa denominator natin, nag-round off tayo. Although maliit lang naman yung layo niya dun sa kapag dinirect natin sa calculator, so mas maigi na gumamit tayo ng calculator. So that is 1.4064. So the z computed value is 1.4064. This one is the answer. Next, okay, the population proportion is 0.36 and n equals 250 and the sample size is 250. The sample proportion is 29%, or that is 0.29. So, kailangan natin kunin yung value na q. Okay, so 1 minus p or 1 minus 0.36, the answer is 0.64. So, gamit yung given data na to, substitute natin ng sa formula. So, using this formula, so 0.29, that is our sample proportion. Okay, yung 29% or minus 0.36, okay, the population proportion divided by the square root of, okay, yung P natin, 0.36, times yung Q, that is 0.64, over 250. Okay, using calculator, that is negative 2.3058. Next example. A politician claims that he will receive 60% of the votes in the upcoming election. In a random sample of 500 voters, there are 175 who will surely vote for him. So first, okay, identify natin what is the hypothesized proportion. That is 60%. So yung P is equal to 0.60. So next is the value of Q. So yung Q natin, that is 1 minus P. So since yung value ng P natin is 0.60, 1 minus 0.60 of the value of the value of Q is 0.40. And then yung sample size natin is 500. Our x here is 175, and that is 175 divided by 500. The answer is 0.35. So yung sample proportion natin is 0.35. So kompleto na yung kinakailangan natin para ma-compute natin yung z computed value natin dito. Okay. So using this formula, so substitute all the given data, 0.35 minus 0.60 divided by 0.60 times 0.40 over 500. Using your calculator, the answer is negative 11.4109. So, pag mangutana mo if pwede duha ka decimal lang, pwede depende sa teacher. Pag hanggang 2 decimal places lang, so i-round off nyo up to 2 decimal places.